Good day and welcome to my YouTube channel. I'm Arthur Francis Divine. Today we're going to be dealing with sort, that is mathematics. So I'll try the best I can to have it as simplified as we can. So we say sort are irrational numbers. Alright? There are the roots of rational numbers whose values cannot be expressed as exact fractions. Example, we have root 2, cannot give us exact fraction. We have root 7, root 12. This product of these roots are not exact values. So all numbers who do not have exact values in their root, it tends to be what? Sort. Alright. Example 4. The root of 4 is 2. So the root of 4 is not sort. It's not part of it because it could give us an exact value which is 2. Then, in a simplified manner, we're going to look at the rules which will govern us or help us to proceed with what we're dealing with today. So let's begin with the rules. The first rule, we say the following are the basic rules mostly used when performing operations on sort. So we have rule 1. The root of PQ can also be expressed as the root of P times the root of Q. So this is our first example, which means that if I have a value which is like 12, for example, root 12, can give me root 4 times root 3, or vice versa. Okay, so this goes together, so you don't forget that, it's important. We have the second rule. That first one is the multiplication rule. The second one is the division rule. If we have 2, the root of PQ, this can be as root P divided by root Q. So it means that insofar that we can do it this way, we can also do it this way. If it is in this manner, we can bring it back to this manner. So if I have, example, root 70 divided by 3, I can rightly say this is root 70 divided by root 3. They are all the same. So let's take another rule. It's rule number 3, say addition rule. That the root of P plus Q is not equals to the root of P plus the root of Q. So here, a lot of students make the mistake because here we're able, or in this form, we're able to multiply them and we can bring them together. A lot of students will still make the mistake and think that in the division aspect, the same rule apply, but no, they are not equals to. And the fourth rule, which is the subtraction rule, P minus Q is not equals to the root of P minus the root of Q. It is not. You're going to see why it is not when we proceed with the exercises. Alright, let's take excuse me, an example to represent what we've done so far. Provided both P and Q are positive, in that sense, these are not equals to each other. So let's take one example. If I have root 20, this can become root 4 times 5. This, and this is the same thing as root 4 times root 5. To that end, this still goes. And thereby, we will be simplifying it as we proceed. But that's just the basic. Now, let's look at something. Basic forms of sort. At what level do we say sort is in its basic form? When I say a sort is said to be in its basic form if it does not have a factor that is a perfect square. So if the variable given to me, like root 7, does not have a factor in it that is a perfect square, then it is not in its basic, it is in the basic form. But if I have something like root 9, no, root 12, where I know that this can give me root 4 times root 3. This is 2. The root of 4 is 2 times root 3, which is 2 root 3. So realize that this is not in its basic form. It can only be in its basic form if it cannot give you a number that is a perfect square. So this root 7 is in its basic form because it can't give us any variable that is a perfect square. We also have root 2 is also in its basic form, root 3 in its basic form, root 5 in its basic form. All these variables cannot give us what? Any factor that is a perfect square. Okay, so we understand that. Let's move on. Okay, now we look at similar sorts. Sorts are similar if their irrational part contain the same numeral. Let's take, for example, I have 3 root n and 5 root n. These two sorts are similar. Why? Because the variables inside the root are the same. If I have 19 root 2 and 100 root 2, these two sorts are similar because they have variables inside the root that are the same. But those sorts that are not similar definitely have variables that are not the same. For example, I have n root 3 and let's call it n root 5. These two sorts are not similar. Insofar that there is n here, there is n here, they are not similar because the variables inside the root are not the same. It's like saying, here, I have 3 apples. This is root n. If we decide to call root n an apple, there's another root n. So anywhere I see root n, I call it an apple. So I have 3 root n and 5 root n. I can easily say I have 3 apples and 5 apples because they are the same and I can add them. But if root 3 tends to be apple, root 5 is bananas. I cannot say n apples and n banana are the same. They are not similar because what is inside defines the sort. It defines it all. So these are not similar sort, but these are similar sort, and the similarity is defined by the variable inside the root. Only by that we can do our addition or our subtraction. Now, let's talk about conjugate sort. The reason why I'm trying to define the variables or the terminologies used is because we are going to use them when we proceed in our calculations without going back to refer to them, so I have to define them at once. Now, in a simple way, let's say conjugate sort. A sort is said to be conjugate in this manner. If I have root 3 plus root 2, its conjugate becomes root 3 minus root 2. Why is that? Because in the course of our rationalization, it is only in this form that we'll be able to get rid of the root sign, which tends not to be in the denominator or the denominatorial pattern. So in that fact, this is its conjugate. Just know that when you have root a plus, or let me call it minus root b, its conjugate becomes root a plus root b. So I don't need to give us plenty language there. Just know that the conjugate is to change if it is plus, become minus. If it is minus, become plus. That's that. Just take note of that. So let's just simplify sorts and see how far we can go with the understanding or the things we have said so far. So we'll look at simplification of sorts. Let's simplify the first one being root 45. So the first one here is root 45. Now, I will show us, if you remember your lowest common multiple very well, so I'm trying to show us the easiest way in which we can break down a variable to its simplified form. so that you can deal with it or any variable given to you without problems. So now this is root 45. If I want to simplify it, first of all, it's good to do this way. You have your 45 here. Now, 45 divided by 5 will give you 9. These 3 go here will give us 3, and 3 go here will give us 1. So, why am I simplifying the surd? The reason is, I want to get a variable inside this number which can give me a perfect square. If I can get that, it means I can simplify or break it down further. Otherwise, I'll be stuck because root 45 is not a perfect square. It cannot just give me a direct answer. Like root 9, which is 3, root 45 is not going to give you a perfect answer. So, I simplify it by creating a variable inside of this 45 that is a perfect square. So, by me doing this, I know that 3 times 3 is 9. And when two numbers can multiply themselves to give you a product, that product is a perfect square. 2 times 2 is 4, the root of 4 is 2. 3 times 3 is 9, the root of 9 is 3. 10 times 10 is 100, the root of 100 is 10. So it means that 3 times 3 here, which is 9, I can now have 9 and 5. Because 9 times 5 will give me 45. So, according to the multiplication rule of surds, it means that if this is correct, therefore I can also have this to be root 9 times 5. We said that in the multiplication rule. So, and if this is also correct, it means that we can also have root 9 times root 5. That is the law. So, now we know that root 9 is a perfect square. That is the essence why I try to get a perfect square in the process of simplifying it. So, root 9 now will become what? 3 times root 5 or 3 root 5. Any of these. So, by so doing, I have simplified the surd to the lowest what level. So that is all about simplification. Let us take another variable. Let's say root 98. Number 2. We have root 98. So, like I said, our lowest common multiple knowledge has to be applied also. So let us try to break this down. I have this, and this is my 98. So, the easiest way to begin with is to divide it to get numbers that can give me what? A perfect square. So, I start with 98 divided by 2. I have 49. 2 go here gives me 49. Now, 2 cannot go there again. And perhaps I know that 3 will also not go. But 7 can go. So, 7 go here will give me 7. And 7 again will give me 1. So it means that 49 times 2 is 98. Why do I have to present it in this manner? Because I know that these two numbers can give me what? A perfect square. And this one, although will not. Then, according to the multiplication rule, I can therefore say I have 7 times 7 times 2. Which is 49 times 2. This is also the same thing as root 49 times root 2. And I know root 49 to be what? 7. So this becomes 7 times root 2. Which is the same thing as 7 root 2. So with this, I have simplified it. But my ability to know that the easiest way to go through the simplification is first of all to break the variable or the number into different factors that 2 of them at least are the same, which can give me what? A perfect square. If there are 4 of them that are the same, they can still give me what? A perfect square. Okay, let's take another one to simplify. Let's take root 240. So root 240, I can still do the same thing. I come back here, put my 240. I use 2 first. So I want to break it down. 240 divided by 2 gives me 120. We'll continue small. Divide by 2 will give you 60. 2 go here now will give us 60. 2 go there again will give us 30. 2 go here again will give us 15. So 2 cannot go again. 3 go here will give us 5. And 5 go here will give us 1. But I know that these numbers, 2 times 2 will give me a perfect square, times 2 again will give me a perfect square. So which means 4 times 4 will give me a perfect square, which is 16. 16 times 15. So now, I can easily come here and say 16 times 15. Now, 16 times 15 is 240. So you know that you're correct. So if this is a perfect square, this is a perfect square indeed, and according to the multiplication law of Surds, it means that I can still break this down into root 16 times root 15. And I know root 16 being a perfect square will give me 4 times root 15. And this means it's 4 root 15. So with this, we can simplify any variable, provided we have the understanding or the common sense that we can break down the variable, no matter how big it is, into something we can make use of. Let's simplify one last one, and so we'll move on. Let's take root 50. Root 50. I'll come back here again. I say 50 is here. 2 go there will give me 25. 5 goes there will give me 5. 5 go here will give me 1. So it is the same thing as 25 times 2, which we know that is 50. So I'll come back here and say 25 times 2 is the same thing as root 50. That's the multiplication rule. So if this is true, and I move on to say this is the same thing as root 25 times root 2. And the root of 25 being a perfect square is 5 times root 2. And this is 5 root 2. So by simplification, we move on gradually. So with our knowledge of breaking it down to the lowest common multiple, we'll be able to get all the factors of that variable. And we'll be able to also know those factors that are what? Perfect squares. And as such, we can thereby proceed to simplify our solved. Now, let's say the next one we're done with simplification. Express the following as a single Surd. To express a Surd as a variable as a single Surd, let me break it down. Let's take one so that I can explain. We have 2 root 5. 2 root 5. They say we should express this as a single Surd. It means that we should turn this variable all into one root. There should be inside one root, like root 10 or root 20 or root 30. But it should all be inside one root. Inside one sign or symbol or inside one root. For us to do this, in mathematics, remember, whatever you are doing to a particular number, ensure that the variable does not change its position or its value. It doesn't diminish or increases. It maintains its status quo. So let's see, how do we do that? I want to put this inside the same Surd, but the same variable too should be maintained. It shouldn't be changed. So the only way I can do that, for example now, instead of me to put root 2, if I put root 2, it is not the same thing as 2. It's different. So what can I do to maintain this 2 itself? I will do it this way. I'll square it. Now, why should you square it? First of all, remember, the root sign. Let's discuss, okay? The root sign is the same thing as 1 over 2. Alright, and I want to maintain 2. They gave me 2 that I should put it inside the root. So this is root 2. I want it to be inside a root that maintains its value as 2. So for me to make this 2 be inside a root and maintain its value as 2 is this. I'll come here. I have my 2, which is given to me. And I know that when I square it is 4 and root it becomes the same thing. How? Because this root is the same thing as 1 over 2. It means that 2 raised to the power 2 raised to the power 1 over 2. This is what this variable now means. But how is this variable 2? Is this. according to the Powers law of indices, it says that when a number is raised to a given power, which is again raised to another power, that this number 2 is said to be in powers, that the powers are multiplied together for final result. It means that 2 raised to the power 2 times 1 divided by 2. 2 times 1 is 2, divided by 2 is 1. So 2 raised to the power 1 is 2. So for me, to root, square and root the variable, maintain that variable is still 2. Because I can prove here, using laws of indices, that chemistry or that reaction still maintains the value 2. So, in a simple way, if I say put 3 in sort form and make sure it maintains its value, you should know that you are going to square it and root it. If I give you 9, put it in the sort form and it maintains its value, you put 2, square it by 2 and put your root. That is how the chemistry goes. You should always remember these indices will help you through. So now, having said that, I can easily come down here and say this variable is the same thing as the root of 2 squared. This times the root of 5. That is what it means. This means 2 times root 5. 2 root 5 means 2 times root 5. So this is the times here. So here is root 2 squared is 4 times root 5. And I know that multiplication law says I can make it as root 4 times 5. The same thing as this. And this is the same thing as root 20. So by so doing, this variable, they said I should put it in a sort form. I've been able to do that, and the answer is root 20. Let's take another one. 17 root 2. 17 root 2. Since I've discussed that earlier on, that the easiest way to go is just to root it and square it times the root of 2. So now you ask, what is 17 squared? That is 289. So here become root 289 times root 2. Now, it's the same thing as multiplying 289 times 2. That gives me root 578. So by so doing, I've been able to put it in the same form, in the same sort form. They say express the following as single sort. They are now what? A single sort. Maybe we should take one, maybe two other examples. I have 5 root 3, which is the same thing as root of 5 squared times root 3. And this is the root of 25 times root 3. And this is the root of 25 times 3, which is the root of 75. Another one. 4 root 3. 4 root 3, this is the same thing as the root of 4 squared times root 3. The root of 16 times root 3. The root of 16 times 3. Don't forget that. Okay, now 16 times 3 is 48. So this becomes the root of 48. You don't forget what we said. You root it and square it. Multiplied by the root 3. The square of 4 is 16. Or are still in the same root times root 3. Now, 16 times 3, which is this, I can now put it in this form. Multiplication law of sort permits that. And when I do that, I have root of 48, which is still allowed. Let's take one more example on that. 7 root 6. So we have 7 root 6. This becomes the root of 7 squared times root 6. 47 square, which is 49 times root 6. And this is the same thing as 49 times 6. And that is 49 times 6, 294. This is the root of 294. So now we can express any surd as a single, any variable as a single word, surd. So let's look at addition and subtraction of surd. In addition and subtraction of surd, remember very well, we talked about similar surd and surd that are not similar. It is that principle which we are going to use to deal with what addition and subtraction of surd. Okay, only surd in the same basic form can be either be added or subtracted. Sometimes there may be need to simplify such surd before doing either the addition or the subtraction. So they have to be in their basic form. Why? If I have root 20, let's say plus root 30, I can't just add them. You have to sometimes simplify it to be in the form whereby they cannot be simplified further. And that is where you know whether you have to add them or subtract. Because by so doing, you'll be able to see surd that are similar that you add, or those that are not similar, and so on. So in this manner, you can't tell whether there are similar surds here or there are not. So let's take our first example. Evaluate root 32 plus 3 root 8. Root 32 plus 3 root 8. Let me confirm that. Root 32, okay, where are we? 32 plus 3 root 8. So like they said, we have to simplify when needed. So we can see what to do. So 32 first, I want to simplify it. This is my 32. 2 go here will give me 16. 2 go here will give me 8. 2 go here will give me 4. 2 go here will give me 2. 2 go here will give me 1. Same. So 4 times 4 is 16 times 2 will give me this 1. So I can easily come here and say 16 times 2 for 32. Plus, this is 3 root 8 is 4 times 2 will give me 8. The same thing here. So I have 8. 2 will go here will give me 4. 2 will go here will give me 2. 2 will go here will give me 1. So this 2 is a perfect square. That's 4 and 2. So now I proceed. This is the same thing as root 16 times root 2. Plus, this is 3 times root 4 times root 2. Now, this is a perfect square. Root 16 is 4 times root 2. Plus, this is 3 times root 4 is 2 times root 2. Now, this gives me 4 root 2 plus 3 times 2, 6 root 2. Remember, we say we can only add surd that are similar. If you check here, we have 2 root 2. We have here root 2. They are similar. So they say 4 root 2 plus 6 root 2 will give us 10 root 2. So this is like 4 apples plus 6 apples will give us 10 apples, which is now 10 root 2. So that's how that goes in the addition of surds. Let's take another example in terms of addition. Okay. Evaluate 7 root 3 minus 7 root 3 minus root of 75. Root of 75. Okay, that's correct. So this one is already in its basic form. We can't break it further. So, but this one is not. We have to simplify this to take it to the basic form. So I will draw my table as usual. 75. So 75 divided by 5. 5 goes here. Will give me 35. Oh, 15. Sorry. Will give me 15. 5 go here will give me 3. 3 go here will give me 1. So this is 25 times 3 will give me that. So now, I now have 7 root 3 minus the root of 25 times 3. 25 times 3 is 75. I'm trying to simplify that. So I have 7 root 3 minus the root of 25 times the root of 3. 7 root 3 minus root 25 is 5 times root 3. So 7 root 3 minus 5 root 3. Now, root 3, they are similar. It's like 7 apples minus 5 apples will give us 2 apples. So 7 root 3 minus 5 root 3 will give us 2 root 3. Okay. Let's take another one. Evaluate 3 root 48. 3 root 48 minus root 75 minus root 75 plus 2 root 12 plus 2 root 12. So 48 and 75. So let's break this down. So first of all, start here. Our 48 as usual, don't forget that. This is 24. 2 go here will give us 12. 2 go here will give us 6. 2 go here will give us 3. 3 go here will give us 1. So this is 4. 16 times 3. So when you confirm that 16 times 3 will give you 48. So we come here and say 3 times 16 times 3 minus 75, which is 25 times 5 times 3. I've done this just in the previous example, so this is 25 times 3 plus 2 root 12 is 4 times 3 will give us 12. So I want to break that down. I have 3 times root 16 times root 3 minus root 25 times root 3 plus 2 root 4 times root 3. So when I come down, I have 3 times root 16 is 4 times root 3 minus 25 is 5 times root 3 plus 2 times root 4 is 2 times root 3. 3 times 4 is 12. 12 root 3 minus, this is 5 root 3 plus 4 root 3. Now, 12 apples minus 5 apples plus 4 apples is what? 12 plus 4 is 16. 16 minus 5 will give us 11. So all of them are 3, 3, 3. So that gives us 11 root 3. So you can confirm that 12 minus 5, which is 7, plus 4, which is 11. So that's what we have. So by simplifying it further, that is where it will take us. So don't forget, addition and subtraction of sum have to deal with variables that are similar and they must be in their basic form. So whatever is given to you, you have to simplify it to its basic form first before you add or you subtract. And for you to add or subtract, that means that the variables are either similar. That is where you can add them. Otherwise, you cannot. Okay, quickly, let's look at multiplication of surds.